All right. As you're looking at this equation, you may not know what equation, what conic section you have. Although we know because it was given in the section of, what is this, hyperbolas? Ellipse, okay, yeah, because we have x squared, y squared, they're both having the same sign. That's an ellipse. First step, move everything on one side, on the left, right? So this 8x and 48y should be moved on the other side. How do you accomplish that? You're basically subtracting 8x from both sides, subtracting 48y from both sides. An easy way, just take them on the other side and change their sign. So what is this expression becoming now? I have one. Plus 4y squared minus 48y plus 124 equals 0, right? Alright, well, you're looking at the first two terms here. The terms that contain x. What should we do here to make it a perfect square? If I have x squared minus 8x, I'm looking for what number should I add here to make this one a perfect square. What number should we add? Well, you're always looking at your first degree x coefficient. What is that? 8, right? Negative 8. So it'll definitely be an x minus something. And that something will be actually half of this 8, right? Which will be 4. But you have to square it and plus 16. Because you don't want to change the value of your expression, you will subtract that 16. Okay? Now you're going with the y part, right? I have 4y squared minus 48y. But because I need to have only y minus something, everything squared, when I will find what binomial square will give me, the expression of, in regard to y, the expression that contains y, I will take that 4 as a common factor. It will be plus 4 times what? What do you have left? Good. Minus 48 divided by 4 is 12y, right? And now I need to know, I'm looking at just at my y squared and negative 12y. I need to find what number should I add here to have a perfect square. And like I said, check your first degree y coefficient. What is that? 12, right? You divide that by 2. That would be 6. You square it, and that tells you what you have to add here to have a perfect square. The 36. You add 36, you take away 36 because you don't want to change the equation, right? And then I have plus 124, everything equals 0. Now, looking for my perfect squares here, right? That's one of them, and then the other one. I mean, we did it in such a way that there will be a perfect square. What binomial square is this one? It will be x minus 1. What number square gives you 16 here? X minus 4, everything squared, right? I'm going to leave this minus 16 for later, negative 16, right? And then I have plus 4 times y minus 12y plus 36 is what binomial square? Y minus what? What number squared gives you 36? Minus 6. Everything squared. Now, I have, you can put plus 124, was already there. And now I have minus 16. And don't forget about this 4 needs to be multiplied by that negative 36, right? That this is still here. So it'll be minus 4 times 36. 4 times 6 is 24. 4 times 3 is 12 plus 2 144 equals 0. Alright? Now what is 124 minus 16 minus 144? We can go first with 124 minus 144. That would be negative what? Negative 20, right? Negative 20. Negative 20 minus 16 will be negative 36, which will move it on the other side. You will add 36 to both sides, which will cancel this one and will give you a 36 right here. Right? So the equation is actually looking like this now. X minus 4 everything squared plus 4 times y minus 6 everything squared equals 36. Now, for me to have an equation of an ellipse, I have to, my expression here should be equal to 1, right? In order for us to have a 1 here, I will divide everything by 1. By 36, or we should use brackets here. I'm dividing the whole thing left and right by 36. And I have x minus 4 squared over 36. I will keep changing the colors here to make it prettier. So I have x minus 4 squared over 36. What 36 is what? 6 squared. Plus, well, as you can see, 4 times y minus 6 squared divided by 36, what's going to be that? 9, right? So I have y minus 6 everything squared over 9, which 9 is 3 squared, equals 1. And this is the equation of your ellipse in standard form. Looking at this equation, you can answer many questions regarding the center, the vertices, the foci, right? Where is the center of this ellipse? Center will be located at what? 4 and 6, right? This is your H, that's your K, right? Where are my vertices? Now, before we do that, how is this ellipse oriented? Is it horizontal or vertical ellipse? What is your major axis? Your major axis will be horizontal or vertical? Well, which one is bigger here? A is bigger, right? Because this is, your standard equation of an ellipse looks like x minus h squared over a squared plus y minus k everything squared over b squared equals 1, right? And whichever of these two is bigger, or if you have y minus k squared over b over a squared, whichever one is bigger, that's your major axis, right? If it's under your x, it's going to be horizontal. If it's under your y, it's going to be a vertical oriented or a vertical major axis. So for this one will be which way? Horizontal or vertical? Horizontal, right? And if you have to graph it, you will need your coordinate system. Is this problem asking you to graph? Okay. Y-axis, axis, right? My center first. 4 and 6. 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. As you can see, I'm using different scales on each one of the axes. I'm trying to make sure that my ellipse will fit in here, right? And the intersection of, parallel to each one of the axes through these two points will give you the center. That's the center of your ellipse. Now, you said it's going to be horizontally oriented, right? Because your major axis is horizontal. Well, how can I find where my vertices are? What do I need for that? I need my A, right? My A is how big? 6. It means 6 units to the left and 6 units to the right of your C. You will have your vertices. 1, 2, 3, 4, 5, 6, right? So that would be negative 2. Right? So negative 2 and 6. That's your V1 if you want, your first vertex. And again, 6 units to the right from here. 1, 2, 3, 4, 5, 6. That will be my second vertex, right? Now you can go with the transverse, with your vertical axis here, right? Your other axis, which is the conjugate axis, right? Which is given by your B. You go 3 units up and down from your center. Three units up, 3 units down. 1, 2, 3, right? Will be 1, 2, 3. Will be here, and the other one, 1, 2, 3. Will be there. Okay. And you know, I can graph my parabola right away here without finding anything else. As you can see, knowing the vertices, my parabola will look like this. Okay. Now, if the problem is asking you to find the foci, how can you find that? What do you need to find that? What do you know? Well, you need to find C, which is the distance from your center to your two foci, right? And you have to find C. And for an ellipse, your relation between C, A, and B is that C squared is A squared minus B squared. And you just plug in your values. What is your A in this case? A squared, 36. B squared, 9. And what you have here? 27. Which means your C will be square root 27, right? And that is what? Square root of 9 times 3, which equals 3 square root 3. That's 5 point something, right? And this means you go 1 from your center, you go 5, 3 square root 3 units to the right, 3 square root 3 units to the right, to the left, and you find your foci. 1, 2, 3, 4, 5. It's here somewhere. Let's use dark blue. And the other one, that's F2 if you want. The other one will be 5 units, 5 point something units to the other side. Will be here somewhere. That's your F1. And that's all. If you want, you have to write their coordinates. You can say, well, F1 has what coordinates? H minus C, right, which is 4 minus 3 square root 3, and the same Y, 6. F2 will have the coordinates 4 plus 3 square root 3 and 6. You can mention, if you want, the vertices. Your V1 will have the coordinates what? 4, H minus A, H plus A, right? So it will be 4 minus 6, which is negative 2, and your Y stays the same, K, right? And the other one, V2, will be 4 plus 6, which is 10, and your K stays the same. And this is it. We wrote the standard equation. We we graph it, we graph this ellipse. We're pretty much done. Ryan, you